Good afternoon. My name is Dr. Sherry Sizemore, and I'm going to share with you a lesson on solving linear equations in algebra. I have to tell you, algebra is one of my favorite branches of math, so I'm very excited to share with you some things that might help you understand equations better and solving them and so forth. As you can see, I've kind of subtitled this a balancing act, and I've used a scale up here for a visual to help you understand how equations work. And so whenever you've got something on both scales, you obviously want to keep it balanced. And if you remove something on one side, you need to remove the same weight or the same total from the other side. If you add something on one side, it needs to be the same on the other. And that's basically the principle of solving equations in algebra. A few things to remember, and I've already said this. Linear equations have equal signs. You do the same operation on both sides, so if we do addition on one side, we do the same addition problem on the other. Multiplication, division, subtraction, so forth. And then one of our goals in solving equations is we want to get all of the variables on one side of the equation sign and all of the non-variables on the other side. But our ultimate goal in solving equations is to isolate the variable to determine its actual value. So we're going to work a few problems today, and the first one I'm going to do is 4x plus 5 equals 13. I've redrawn the scale. I'm not going to do this for every problem, but I wanted to show you this one because I wanted for you to get a better idea of how the scale and the balancing act helps you in solving equations. So let's think of this as the equal sign. And what I'm going to do is I'm going to take this, which is our unknown, 4x's, and I'm going to represent them as 4 boxes down here. Each of them with a value of x. Okay, and then on beside it, I'm going to show our 5. 5 is our constant. So I'm going to show those with 5 circles. Over here we have another constant, which is 13. So I'm going to display that as 13 circles. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13. Okay? So whenever we are trying to balance this, remember our goal is to get all of the variables on one side, which x is already on one side. We don't have any x's on the right side. And all the non-variables are our constants on the other side. So what we want to do is we want to go up here, and we obviously want to isolate x. So the first thing we're going to do is we're going to take away 5 of these circles on this side. To represent this down here, we're going to show it as subtracting 5. Over here, we're going to do the same thing. We're going to take away 5 circles. We're going to show it as subtracting 5. I like to put an equal sign here to remind myself that those have to be the same. They have to be balanced. And then let's look at what we have left. We have 4 x's left over here. We have 8 circles left over here. We add our equal sign because we want to keep them balanced. So if you go back to this problem, you look at positive 5 minus 5 is 0. So 4x plus 0 is 0. 13 minus 5 is 8. So now what we have to do is we have to say, okay, we've got 4 x's over here, we've got 8 over here. We want to isolate this, so we want to find out what is the actual value of one of these x's. Well, since we have 4 over here and we have 8 over here, I can see that I can divide this up evenly by 4 groups of 2. So that when I do this algebraically, I want to show it as dividing by 4. So I'm going to divide these by 4. I'm going to divide these into 4 groups. I'm going to show it as, that looks like a fraction, but I see it as a division problem. 4x divided by 4 is x, because these cancel. 4 fourths is 1. 1x is x, equals 8 divided by 4 is 2. So if we put that 2 in place of these x's, we can say 2, 4, 6, 8, 9, 10, 11, 12, 13, which is what we have on this side. So that checks our problem and shows us that x has a value of 2, and that is correct.